Welcome to Lesson 19, Extending Right Angle Trigonometry and Finding Trig Values. So in this lesson, what we're going to do is we're going to move out of just using angles in triangles, and we're going to start placing those triangles on the XY plane and putting angles in standard position and extending being able to find sine, cosine, and tangent and the other ratios to angles that are larger than 90 degrees. Okay. So in order to do this, we're going to start with a circle. And we're going to come up with a new definition for sine, cosine, tangent, etc., based on putting a triangle inside of a circle. So it will be based on our original setup with triangles, but it will allow us to extend the idea of making these ratios outside of a triangle. So we're going to start with a circle of radius r. So remember, radius means the distance from the center out to the edge of the circle. That's what a radius is. Okay. And we're going to actually put this inside of x and y axes. So it's going to be centered. This is my x and my y. It's going to be centered at the origin. This is the center of my circle. And the radius is r, so that means like this point out here and out here, these would all be at r distance from the origin. Okay. And then what we're going to do is we're going to draw that angle, theta, in standard position. Okay, so if this is the terminal ray of the angle, right here, it's in standard position. You can see that it intersects the circle at some point. So we're just going to call that point x, comma, y. We'll just call its coordinates. Let me zoom in just a little here. X, y. Now, what we're going to do is we're going to drop down this perpendicular line directly from that point so that this makes a right triangle. Okay. So now we have a theta inside of a triangle. It's a right triangle. And if you look carefully, if the coordinates of this point are x and y, doesn't that make this length right here x? Because this would be the x coordinate, right, of that point, and this would be the y coordinate. So by this point being x and y, we can see that this side would be x and this side would be y. So I'm going to label this side x, get rid of this x just so it's not confusing, and this side y. And can you tell me what the length of the hypotenuse would be? From the center of the circle out to the end of the circle would be r. It's the radius. So simply by putting this angle and therefore triangle inside the circle and giving that intersection point a name, we could now say what the sine, cosine, tangent, all of those things would be of this angle, right? The sine would be opposite, opposite over hypotenuse. We would flip that for the cosecant. The cosine would be adjacent over hypotenuse. So again, we're using theta, adjacent, opposite, and hypotenuse. So flip the cosine for the secant, and tangent would be opposite over adjacent. And flip that for the cotangent. And so what we're going to do is use this as the basis of a new definition of what sine, cosine, etc. are. Okay. And you can see our second definition here. What the point of doing this will be to allow us to expand, applying these to other angles outside of just acute angles. So here's our second definition. If theta is any angle in standard position, it no longer has to be an acute angle inside of a right triangle. And xy is the point on the unit circle. So we made this circle here. We made this circle radius r. So for the unit circle, that's a specific circle, same location, centered at the origin. But in the unit circle, the r is 1. That's why they call it a unit, because the radius is 1. So we're going to refine this just a little in our definition here to make the radius of the circle we're talking about be 1. Okay, so back up just a sec. So xy is the point on that unit circle, radius 1, that intersects the terminal ray. So just like how we had here, xy intersects this terminal ray, but now this side, instead of being r, will be 1. So down here, every place that I see an r, I'm going to replace it with a 1. Okay, so that makes the sine y over 1, so we'll just call it y, and therefore the cosecant would be the reciprocal of y. The cosine, which would be x over r, will just be x, and flip that for the secant. And the tangent, there was no r in the tangent, so it remains y over x, and the cotangent is x over y. Now, remember that this angle was intersecting the unit circle at this point xy, and notice that x is cosine of that angle and y is sine of that angle. So the terminal ray is going to intersect the unit circle at this point, cosine theta, sine theta. In fact, if you know that point of intersection, it's going to tell you the x coordinate is the cosine and the y coordinate is the sine. So that definition comes from this picture that we did in the first quadrant, but we can now apply it. If I draw an angle over here somewhere and I can identify what this xy is, the x will be the cosine, the y will be the sine. And by the way, you might have seen if tangent is y over x and y is sine and x is cosine, we actually just learned an interesting fact that tangent is in fact sine over cosine, which we're going to use more later. But you could still find it by just doing the y over the x. So let's look at a few examples, just applying this. If the terminal side of the angle theta goes through this point, so I'm being given coordinates of a point on the unit circle. So terminal side, unit circle. Those are the keys that we need to know that those coordinates are literally just the cosine and the sine. Then what is the sine? Well, I just have to report back what the y coordinate is. If it had asked me what the cosine was, I would just report back the x coordinate. If it asked me what the tangent was, I would just do the y coordinate over the x coordinate. Obviously, I'd have to simplify. Okay, and I want to just show you this in a triangle so you believe me that we are still dealing with a triangle. So if I were to look at this ordered pair, positive x, negative y, when I go to graph that, positive x, negative y will be in the fourth quadrant. That was a beautiful line. Some of my best work here. So I'm just going to plot this point. Now, I don't know exactly how far. I'm going to do it probably not drawn to scale, but I'm going to go out 2 root 5 over 5 and down. So maybe somewhere about right here. Okay, that is this point. And then I'm going to connect, well, again with the straight lines. I'm going to attempt to make the triangle that goes with this. So this would like be my R, right? And then I drop that down. So my X here is 2 root 5 over 5. Remember, that's the X coordinate. And Y here, that's the Y coordinate. And my radius, it's the unit circle. So my radius is always 1. Okay. And so now if I was looking at this as my angle, I can do a cosine, a sine, a tangent, etc. So you don't have to draw the triangle every time, but I just wanted to point out that when you have that point, it does still give you the opportunity to create a triangle so that it lines up with our intuition of what we've already done with triangles. Okay. So same idea for number 2. Suppose the terminal side of an angle T, terminal side, goes through this point on the unit circle. Okay. What is the cosine? Well, cosine is just going to be the x-coordinate. Now, I'm going to do this one as a triangle as well, but I'm going to do it slightly differently. And again, I'm just trying to kind of get you to think sort of with some common sense here. Remember how sine and cosine, this would be, if it's cosine, adjacent over hypotenuse, opposite over hypotenuse. Same up here, adjacent over hypotenuse, opposite over hypotenuse. I could have labeled this triangle using that convention, and I'm going to do it this time. So you can kind of see what my point is I'm going to try to avoid fractions. I know you were with me on this. Can I avoid fractions? Yes, you can. So let's see, negative x, negative y, negative x, negative y. That would be the third quadrant. So this time when I make my point and I draw my angle that reaches that point and I drop it down, always to the x-axis when you drop it down, by the way. If this is my cosine, I'm going to think of this as adjacent and hypotenuse. So here's my angle, always from the origin, adjacent, hypotenuse. And if this is sine, it would be opposite hypotenuse. Opposite hypotenuse is already there. Now I have a triangle where I could still be setting up opposite over hypotenuse, adjacent over hypotenuse to get these things. We'll talk about why they're negative in a few minutes. But for now, just in terms of the signs or the sides, the amounts, I have a triangle that still gives me these cosines and sines, but the sides aren't fractions. Okay. So I kind of like to connect them to triangles because I feel like triangles is sort of a lot more easy to understand than a random point of intersection on a circle that seems sort of esoteric. Okay. And at this point, the whole reason that they're negative is because of the x and y directions. So even though I wouldn't usually call, a side of a triangle negative, I could in fact consider this -5 or 5 and 12 to both be negative, since it is in the negative x direction and the negative y direction, which is what gives me, like we said, that -5/13. The hypotenuse in that case would always be positive. Okay. So because of this, as we're extending this new definition, it allows us to kind of note the signs of the various trig ratios. So we're going to make a little quadrant map here. Okay. In quadrant 1, my x's are positive and my y's are positive. So that means that my cosine and my sine are both positive. My tangent, which is y over x, is also positive. And so then all of them, when we take their reciprocals, would be positive. So in this quadrant, all are positive, all of my trig ratios. And that matches what we were doing. These are all acute angles. So if we drew them into triangles, they would all have positive sides. We're good to go. What about in the next quadrant? So if I'm in the second quadrant, the x is negative, but the y is positive. So that means cosine is negative, sine is positive, and if I divide them, the tangent would be negative. So everything's negative except for sine and its reciprocal. So we're going to talk about this in just the 3 sine, cosine, tangent, and then we will assume that when you flip it, you realize the sign would be the same, right? If it was negative, when you flip it, it's still negative, etc. So we're going to label this one as sine is positive and it's reciprocal, all right? So moving on to the third quadrant, in order to put a point here, I would have a negative x and a negative y, which means cosine is negative, sine is negative, but when I divide them to get tangent, a negative over a negative would be positive. So tangent is positive and its reciprocal in the third quadrant. And last but not least, I would have a positive x and a negative y to put a point in the fourth quadrant. What does that make as our sole positive here? Cosine, right? Cosine's positive, sine's negative, divide them, tangent would be negative. So cosine and its reciprocal, which is secant, right? So we have another mnemonic, a way for you to kind of remember this. And that would be ASTC. And that stands for all students take calculus. Yeah, it's not brainwashing, I promise. And what that stands for is the A is that they're all positive in the first quadrant. S stands for sine is positive and it's reciprocal in the second quadrant. T, tangent is positive and it's reciprocal in the third quadrant. And C, cosine. So you just have to be careful because the S and the C stand for sine and cosine, not secant and cosecant. So that is another helpful way to just kind of remember which ones are positive and negative in the different quadrants. And for me, I'm going to go through the rest of this lesson and we're going to learn about reference angles and reference triangles and things. And I do not memorize the unit circle. Let me actually pull up a unit circle for us real quick. Okay, so here's what I mean when I say I do not memorize the unit circle. Okay, hold on, let me just find my pointer real fast. Okay, so what generally happens once people learn the unit circle is they'll say, okay, if I were at 30 degrees, that point of intersection would be square root of 3 over 2 and 1/2. If I was at 45 degrees, and if I was at 60 degrees, remember these are our special angles that we learned in the last lesson. We can write down what their cosine and sine are, and then make those the x and y coordinates here because that's the new definition. And then we can translate them around to the same idea if this was a 30 or a 60 or a 45 triangle in this quadrant, memorize those points of intersection, or in the third quadrant, or in the fourth quadrant. And so what people will do is literally memorize all of these points of intersection. And there are patterns to them. I know this. And so they'll memorize these, and then they'll use this as the way to tell what the sine, cosine, tangent, etc. of all of these different, what we'll call special angles are. And it is a legitimate way to do it. I find personally that it gets really disconnected from what trigonometry is actually doing. And now what you end up doing is memorizing a pattern of numbers. And if you memorize it wrong, that's a big problem. And I have a simpler way to do it. Let me just put it that way. I have a way to do it where you're not stuck trying to memorize this pattern. If you want to do it, I'm not going to stop you. However, what I will do is use the unit circle for these 4 angles here. For 0, 90 degrees, which is pi over 2, pi, or 180 degrees, and 3 pi over 2. Because the points of intersection, if this is the unit circle, this point here is just 1, 0. I don't have to memorize that. This is the unit circle. This point of intersection is 0, 1. This point of intersection over here will be -1, 0. This one, 0, -1. Those are so easy to just not even remember, just know, because it's a circle of radius 1. And then I can say, oh yeah, let's see, the cosine of 0 degrees is, or 0 radians, is 1. The sine is 0. The tangent is 0 over 1, which is 0. And that makes it a lot easier. Okay. So when I'm going to go back now, I'm going to try to go back. All right, so now that I'm back to my notes here, oh, I've got these lovely circles all over my notes now, which I will try to erase. Yay. What I am trying to say is that what I like to do, or what I like to use the unit circle for, are those 4 angles. So 0, 90 degrees, which is pi over 2, 180 degrees, which is pi, 270, which is 3 pi over 2. And then I can just fill in, let's see, that's a 1, 0. That's a negative 1, 0. That's a 0, 1. And that's a 0, negative 1. And now I could answer all kinds of questions like cosine of pi or sine of 3 pi over 2. So that is the one set of angles that I actually use the unit circle for, the second definition. The rest of the time, I'm going to use reference angles, which we will talk about in the next video.